This is Caleph Wilson from, thank you for the introduction, from Miltenyi. I'm the field application scientist that supports our Tyto sorter. So we're gonna give you a nice walkthrough of the technology and how it can benefit your work with infectious diseases. All right. All right, so I want to walk through a bit of an agenda. So the first thing is I'm going to walk through an introduction. 1 second. Give me just a second. Let's get the laser pointer going. All right. So we're going to walk through introduction to Miltenyi and talk about sorting safety, the Tyto and infectious diseases, and then the technology that within the Tyto, the cartridge, some safety testing, infectious disease data, and then some considerations for human tissues now, and then conclusion and some supplemental info. All right, so Miltenyi Biotec, our motto is empowering discovery and advancing therapy. And this is a photo of our location in Bergisch Gladbach in Germany. And so some fast facts, Miltenyi was founded in 1989. We have roughly 3,000 employees worldwide, 50 nationalities, 23% of the company is globally is R&D. We have greater than 20,000 scientific applications. We have a lot of a large product portfolio with 7,000 products. We have a lot of products in cell therapy. A lot of patients are treated with our products, and we have direct sales in 28 countries, and we have 73 countries that we serve through our distributors. Here's an image of our locations here in the US. We have a facility in Cambridge, Massachusetts, Gaithersburg, Maryland, San Diego, our Tyto sorting group. The Owl Technologies is based in Santa Barbara. We have a cell manufacturing facility in San Jose, and then an additional operations in Auburn, California. So some histories of the key technologies led to it. So our biomedical technology chip was started in developed in 2013. And then from there, we adapted our CAR-T technology through Living Pharma. We acquired Lintigen, which became a Miltenyi company. And over here, some more background of what we've just gone through. But the point is just to make that Miltenyi is a growing company, and we have a lot of things to offer. And so one of our key points is we have technologies that can get you from the benchtop to bedside. So we have sample preparation, cell isolation, cell activation, expansion, culture, cell analysis with our MACSQuant analyzer, and also imaging platforms. And on the bedside, we have cryopreservation, cell analysis, culture, cell activation, expansion, and also our Contamination platforms that allow us to do some cell processing. Okay, so this next stage, we're going to talk about reconsidering sort safety, why the Tyto for infectious disease, and talk a bit about the cartridge and some safety. All right, so most notably, we're all aware that we're dealing in this COVID environment. And if you look at the tri-state area, as of this weekend, there was over 500,000 positive cases, 20 to 80% asymptomatic carriers, and it's a novel virus with many unknowns. So most cases, if we're dealing with human tissues in this environment, that basically means that we have to assume, especially in a metro area, that those tissues are from people who may have been exposed or are carrying SARS-CoV-2. All right, some considerations for sorting hazardous materials. It can pose a risk to safety of the operator through aerosolizing or how samples are handled. And then it has potential to contaminate other samples as well. So not just the danger of the direct operator who's handling this, but you can have a downstream effect of additional samples that can be contaminated and basically create an untenable situation that's pretty scary for everybody. All right, so some of the things we have to consider when we're using jet air sorters are you may need to be housed in a biological safety cabinet. It often require rooms with special handling systems. Operators may be required to wear ventilators, and the decontamination of the instrument and its housing can be costly, take a lot of time, and be a major process for everyone to engage in to get this taken care of. Also, in the difference of handling things with the Tyto is the Tyto is a closed system. So what the Tyto does, it has a cartridge-based process where that it works on. And the way that we like to think about this is you've taken your sample, put it in a conical tube, take that conical tube, put it into the instrument, and it sorts and concentrates your sample. And all you have to do is take that tube back to the hood or some safe location to open it and collect your sample. It lowers the risk for the operator during the operation and cleaning process. There's no decontamination, so there's no fluidics running through the instrument that you have to drain and bleach and replace. And also there's no chance of carryover from running an infectious disease sample to your next sample. So when the next operator comes in, they don't have to worry about it carried over to their sample. All right, so some ISAC recommendations for COVID sorting. And here we're going to have some excerpts from Stefan and Ben. And so the key thing is that we're going to point out is that infectious diseases can be sorted as in a BSL-2 or BSL-3 laboratory. Two factors that are critical in these practices are the use of aerosols, again, that we mentioned in respiratory protections, if there are aerosols, and then SOPs detailing how you're going to actually clean these instruments when you're finished. Then also we have to test for contaminant on the pre-sort, the select procedure, and then also your filtration time and the sorting procedures, as well as measuring the room for negative air pressure. So we say this to make the point that there's a lot of work involved in this process, and you have to be very careful. So in this COVID environment, what we're thinking about is doing a lot of work and trying to get this done in a safe manner, and everyone's pretty much going to be sorting COVID positive samples, or can be considered to sort COVID positive samples. So here we have a blog post from the University of Chicago's Flow Core, where they're talking about the Tyto and giving a review of the instrument and talking about sterility versus other sorters. And so here we have some contamination testing on the ARIA, where they've gone over a series of months checking the instrument, looking for contamination to make sure there's no ongoing contamination in that instrument. And then the question is, once you've sorted the cells on some additional sorters, can you put them back into culture? And also, when you put your cells back into culture, you want to make sure that you use antibiotics so you don't have any contamination with those cells. And we know how arduous that can be with using things like using various antibiotics to treat your cells, and hopefully those antibiotics don't have an impact on the cells that you've taken all this time and care and money to sort. All right, so decontamination on a droplet sorter, time, repetition equals safety. All right, there's an interesting thread that was on the Purdue list that talked about this. It was led by Jeffrey. And so one of the things that they were saying that they test their sorters every week. They culture samples in with antibiotics and non-antibiotics, without antibiotics, to see how those samples are contaminated. And then they have weekly cleans on Mondays. And then they run quite a bit of bleach through the system to make sure that things are nice and clear. And actually something that Kathleen's mentioned in that conversation is they use, they test the sorters for contamination on Fridays. They run ethanol through the fluidics. They do an ethanol shutdown every week. And in circumstances, you could have a stubborn contamination. And so you have to carry out some additional processes to make sure you actually get the system clean. And for Lola, they test their sorters 3 times a week, Monday, Wednesday, and Friday. Then Joel talks about they always run 10% bleach in their systems between clients to make sure that there's no carryover and the systems are clean. And the key point is we want to talk about this is that there's a lot of conversations, especially now that are going on, and how you actually keep these systems clean and keep them ready to go. And if you can imagine from the flow core personnel who are on here, you do a great job of keeping your instrumentation clean, but that takes a lot of work and you have to be extra careful. And there's a lot of time invested in this that potentially you could be using to actually run sorts for your customers. And so when we do a comparison of the time saving on the MACSQuant Tyto sorter, the startup time is around 15 minutes. The experiment setup is about 10 minutes to get the cartridge set up. The sorting time could be 2.5 hours, depending on max time, depending on what the operator is doing. There's no cleaning required, and then the shutdown is basically turn the instrument off, walk away. So you're looking at less than half an hour that time that the operator is committed. And that key point here is that the operator does not have to be with the instrument for it to operate. Once it's set up and is running, the operator can walk away, go do what they need to do. The instrument will stay at 4 degrees and it will keep that sample ready to go and contained until they return. However, when you think about your droplet sorter, over here on the right, we have a lot of startup processing and things to get ready for the instrument that can take an hour. Experiment setup could take a few minutes. And then if you run the instrument for 2.5 hours, I would be willing to bet that few of you are going to leave your sorters running by themselves, not keeping a watchful eye on them. Post sort, you're going to take half hour to 2.5 hours to clean the instrument, which is what we just went over. And then you're going to go through a shutdown process that may take about 20 minutes or more. So you're basically looking at an operating time of over half a day to get the instrument up and running. So in the comparison, the Tyto could have potentially gone through 4 to 5 additional sorts in the same time that you're setting up the traditional droplet sorter. And so what the Tyto does, it minimizes stress. And talking about functionality, it minimizes stress on the cells, maximizes viability, and then you can also increase capacity. So we're connecting this with the amount of hands-on time that you have to actually go through your sorting process to make sure it's working effectively. So the required features on the Tyto, they're gentle on the cells, so there are no shear forces, so they're not dropping and slowing down when they hit the buffer. There's no decompression. It also enables resorting the cells. So if you have a population of cells that you sort, but also in that non-sorted fraction, you can collect that and then sort that fraction as well. So you don't actually lose any cells. Remember, I mentioned that this is like taking your cells, putting them in a conical tube, sorting them. So if you have your cells contained in the conical tube and you take your sort fraction, you also will be able to pull out your you may also be able to pull out your cells that you didn't sort. They stay sterile, so there's a 0.1 micron filters on the instrument. There's no, on the cartridge, there's no carryover, there's no contaminated fluids. It's safe for the operator because there are no aerosols, and then it may eliminate the need for a biosafety cabinet depending on what you're actually running on the instrument. It's easy to use, it's on the benchtop. There's no adjustments for drop delay, laser alignments needed, and there's no cleaning. So a lot of the traditional processes that we engage in to take care of our sorters, the MACSQuant Tyto has solutions for those if we get the work you need done faster. So in comparison of how this process works, we all know our droplet sorters are charging our cells. It creates a fluidics droplet based on that charge of that particular sample. It gets sorted also based on any fluorochromes. and you can separate out your negative waste and your positive samples. However, your cells are being dropped and they're basically uh, slamming into a wall when they hit the buffer. The Tyto operates in a complete cartridge system. So we have an input chamber. The cells go through here. They're filtered. They are interrogated by the laser. If they have the correct criteria, the valve opens through a magnetic signal. Cells gently roll into the sort chamber, and all the cells that are not sorted move over to this other side to the non-sort fraction. And this is what we mentioned before, that if you have cells that are not sorted, they can actually be taken back over and sorted again, looking at a different population of cells. This would be the context of maybe PBMCs. So there's no charge, no decompression, low pressure. They're mild, no shear forces, no aerosols, and it's a closed system. We'll talk a little bit about the optical bench of the MACSQuant. It has 3 lasers. It has a violet, blue, red laser, 2 channels on the violet, 4 on the blue, and 2 on the red laser. And this is a picture of the Tyto platform itself when you get it. All right, so plug and play systems. We'll play this quick video for the sake of time. I'm gonna skip past this and talk about the cartridge in a little bit more detail. So this is a view of the actual cartridge. And let's talk about some of the parts here. We have a input chamber here. At the bottom of the input chamber, there's a propeller that turns to keep your sample in suspension. It works to keep it from clumping. The center fraction here is where your cells are collected. You can see in size comparison how large this size is to this one. So as your cells sort, they are actually becoming concentrated. The only volume that's collected is the volume around the cell when the valve opens to sort them. On this side is your pass-through fraction, and then the business end of the cartridge is down here in the microchip. If we come over to this end, we can see the microchip. So the cartridge is still oriented in the same way, and it's rotated 90 degrees. And here we see the microchip where the cells come through here, they're interrogated, the valve opens, and then they go into the center fraction, which is here, the sorted fraction on the microchip, and those that are not sorted goes into the negative or non-sort. And as an illustration, the size of the microchip is less than the size of a match head. And here's another image of it, zoomed in. And this is a business end where the valve is that sorts your sample. All right, so quick video talks about how the system works. The audio isn't working. So we have air filtration to get pressurization. And that air is filtered so you don't get any contamination from that process. Your positive fraction is moving, it's mixed, it's moving into your input to your sort fraction. And here's a demonstration of what's happening. The cells that you want to sort are the green cells. Whenever they're detected, the valve opens and pushes those and let those cells gently roll into the sort chamber. All right. Safety features. So also, once you've added your sample to the cartridge, the important thing is now you can actually close it. So this would be the lid to the conical tube. You close those samples, and now they have their 0.1 micron filters on them. So the samples are contained. They will not come out, and you don't have to worry about your contaminated agents leaking out of your cells, leaking out of the cartridge either. So let's talk a little bit about using the Silex D system to look for aerosols. So here's an image from a poster that we had where we did some aerosol testing on the cartridge to test to see if there was any aerosols on it. And the key point that we want to show from this is that we didn't see any escape of samples, and we don't have any droplets that are coming out of the cell. So coming out of the cartridge. So the system is tight, it is contained, and it is safe. All right, so let's get into some data real quick as we wind down. All right, so MACSQuant sorting infectious material. All right, so here's a sort for anaerobic bacteria in an oxygen-free environment. And we have some samples we're going to sort. I'm going to show you the T cell subsets from HIV infected patients. And if we have time, we can get into the sorts 3 and 4 to talk about those data. All right, so anaerobic sorting and droplet sorter versus the Tyto. You have to have all of this equipment. It's contained. You have to make sure you have, your gloves, etc. You have to do a lot of work here to make sure that the process is kept air free and you have control of what's going on versus the Tyto cartridge. And the cartridge is basically the size of a 50 ml conical tube if you want to think about the scale of it. All right, so here we have our input of our bacteria. We have olive oil on top to create a barrier for it. And then here's a sort chamber and then a non-sort chamber. This goes into the Tyto, it's set up, and we're going to sort those samples. And what we see here is in the comparison, we have our input fraction, sort fraction, and non-sorted. And so we do see that we've sorted our bacteria, and the bacteria is going to go into, the key thing is going to go to a low oxygen culture overnight to determine whether or not we actually sorted cells that are viable and have the ability to grow. And those cells, and sorry, the data isn't there, but those cells were able to grow afterwards. All right, so now sorting HIV infected cells from human blood. So we got to collect the HIV positive sample. You got to put it through various density graders to get your populations out. We're going to stain them, give them a live dead stain, and then sort them on the MACSQuant Tyto. So here's the data from that. So, and this is where we talked before about the serial sort. So the first fraction that we sorted was CCR7 negative and then CD45 RA negative populations, which is this one. And after that, we came back for the second sort and looked at central memory cells, which are CCR7 positive and CD45 RA negative. So that's the second sort. We removed the non-sort fraction and sorted a third time and looked for CCR7 positive and CD45 RA positive population. And then for the fourth sort, we went back into the non-sort chamber, added those back, and then sorted the CCR7 negative CD45 RA positive population. So the key point here is that we were able to safely take HIV infected HIV positive samples from a patient, sort those samples 4 times by running through the instrument, removing the non-sorted fraction, and then collecting our samples.
And I just want to let you know we have about 2 minutes left.
Okay, thank you very much. There's a few more slides left. We're winding down here. All right, so when we look at the purity and viability of the subsets, what we see is the effector cells are all those cell types are over 99% viable. The purity of them, to some extent, were pre-sort were low. After they were sorted, they all were roughly over 90–80% sorted fraction. So we were able to take these populations from this to this, and they were all viable after they were checked and sorted. All right, so one last thing we're going to talk about sorting malaria on the instrument. And on this malaria sample, what we see here is that we start off with our sort population here that is roughly 29%. It goes up to 98%, and then the non-sorted fraction still had a few left, and it went down to 13%. So this difference between here and here shows we had a depletion, and then we had enrichment here in our sort fraction. And then we take a look at the spirochetes. We can see that there's some spirochetes and a lot of debris here. However, over here, the sample is very clean. And then on a non-sort fraction, we still see some of the debris that we saw in input fraction. So the key thing is that as they were sorted, they weren't damaged and they came out of the system. All right, so conclusion and supplemental information. So the Tyto is gentler, safer, faster, and cleaner. The Tyto closed sorting system makes the sorting less hazardous for users, and it's straightforward to use. The decontamination is very quick, so all you need to do is take the cartridge out of the instrument, collect your samples, and then discard the cartridge like you would a conical tube. The Tyto can process 4 mil samples in suspension over an hour, and so making the standard cartridge a lot faster than a lot of jet sorters. And we currently have installation in BSL-3, BSL-2 plus, and BSL-2. All right, implementing the Tyto in the BSL-3. We've had success doing that in those facilities. We did the internal aerosol testing, customer testing, and then the flexibility of Miltenyi's service and support to meet our customer needs. The important thing about that, the instrument has the ability to do remote support, so we can work with you remotely, especially given that this COVID environment where visits are minimized. All right, so we have a lot of resources and publications. And so one thing we want to say lastly is Mount Sinai has 2 Tytos that were recently installed, so we trained them last week. And you can speak to them about how easy it was to get up and running on the instrument. And here in this case, the Tyto's in a hood, but however your particular institution decides to set this up, we can work with you to make sure the Tyto operates in your environment and meets your regulations and to keep you guys safe. All right, so to close out, again, I'm Caleph Wilson, application scientist from Miltenyi, and our flow cytometry specialist is Tanya Anderson. And here's our contact information, and we are available to talk to you about, to answer your questions about the Tyto. And from here, I will take questions. Thank you very much.
Okay, thank you so much, Caleph. I really appreciate that wonderful talk. We have 3 questions, 2 which I think we'll be able to answer. Miguel Garcia had asked about the price of a cartridge, but I'd like to steer clear of that and just ask you to reach out to Caleph, as a side, to ask specific questions about that. And then Svetlana,
Absolutely.
What's the minimum volume of the sample which is sufficient to put into the input chamber for sorting? So minimum sorting volume.
The total volume is 10 mils, and you can run a sample that's up to 50 million events per, or say if it was PBMC, 50 million cells per milliliter.
Great. Evan Jellison from up in Connecticut had actually, it's a comment and not a question, but he just said that they recommend the Tyto be operated in a biosafety cabinet for certain biohazardous work. So everyone can read that comment from Evan, just recommending that it goes in the bio cabinet. And then Thomas Miller had a question on how small of a particle have you been able to sort?
I think the bacteria from the bacteria has been the smallest, so very like E. coli maybe. So those have been the smallest particles we've been able to sort. Actually, no, nuclei. So we can't sort nuclei.
Okay. And then just one last question on my end. Have you done any comparison, with molecular profiling when talking about that, it's better for the cells and gentler and everything? Has there been any molecular testing to compare, more traditional means of isolation of the cells versus the Tyto?
So there have been some comparisons. We have I work with a group that's doing ISPCs in Japan, and they've shown that the cells that come out of the Tyto versus their droplet sorter, the cells from the Tyto is better. And we do have some data we can talk to if there's people who have specific information or specific questions. We can share some data with you and have some more in-depth conversations about how the Tyto does not stress your cells, so they're from a background perspective, your data comes out a lot cleaner with the Tyto because it's gentler on the cells.
Okay. Thank you, Thomas. And I'm sorry, Thomas, I was answering the question for him about the particle size. Thank you so much, Caleph. We really appreciate it. And I'll pass it back along to Tina.